we're going to go ahead and get started with our second keynote with Avi Loeb. Avi is, I think, well known to everybody in this audience at Harvard, has written many books. He was going to be an anchor of our author panel this evening. So with that, Avi, if you're online, I'll hand it over to you.
Thank you so much. It's great to be with you virtually. I wish I could have joined you in Tucson. What I'll describe today focuses on the book that I published about 7 months ago called Extraterrestrial. You can see it in the middle of this slide. And if I had to summarize it with one sentence, I would say, when you're not ready to find exceptional things, you will never discover them. A couple of months ago, I published the second book on the search for life in the universe. And it's primarily a textbook, about 1,000 pages long, that I wrote with my former postdoc, Manasvi Lingam, called Life in the Cosmos. And it's intended for scientists planning to work on this very exciting frontier. What you see on the left side is a photograph that was taken by Herlinde Quilbel, a German photographer, in an exhibit that she had at the Berlin-Brandenburg Academy of Science and Humanities. And she came to my office a couple of years ago and asked me to write on the palm of my hand the question that I regard as most fundamental in science. And I said, are we alone? Next, please. So one of the remarkable facts that we've learned relatively recently from the Kepler satellite data is that a substantial fraction of order a half of all sun-like stars host an Earth-sized planet roughly at the same separation as the Earth is from the sun. And that implies that not only we are not at the center of the universe, as we thought early on, and the ancient Greek philosopher Aristotle argued that, and people believed him for 1,000 years because it flattered their ego. Not only we are not at the center of stage, but moreover, what we find in our backyard is not special. And so whenever we thought that we are unique, that turned out to be wrong. And I think that's an arrogant point of view to think that the play is about us. There are more habitable Earths in the observable volume of the universe than grains of sand on all beaches on Earth. Next. And that brings a sense of cosmic modesty. When you look at a painting like the one depicted in this slide of an emperor that conquered a piece of land here on Earth, that is a very narrow-minded point of view to be arrogant and very proud of yourself. Next, please. Because that's not very different than an ant hugging a single grain of sand on the landscape of a huge beach. Next. Next. But I can understand where it's coming from. My daughters, when they were young, they tended to think that they are the smartest in the universe, that they are very special and unique. And that's because they compared themselves only to the family members when they were at home. But when we took them to the kindergarten, they got a better perspective. They found other kids that might be smarter than they are. Next. And our civilization will mature by finding others. Next. Now, most stars formed billions of years before the sun. We know that by observing the star formation history of the universe. You see that on the top right. Next. And since I mentioned that a substantial fraction of sun-like stars have a habitable Earth-like planet, next, then we can imagine many of these stars that predated us that could have had life as we know it here on Earth. And perhaps even one of them was as advanced as we are or more advanced as we are. That's sufficient for them to send artificial intelligence systems into space. And AI systems are currently driving cars, and in the near future, they will make medical decisions, and they can behave autonomously, sort of like technological kids that we educate early on using machine learning, and then we can let them explore the world, just like kids. And you can imagine another civilization slightly more advanced than we are that did that, sent such systems into space 1 billion years ago. Next. And if you equip these systems with 3D printing, they could fix any damaged parts and they could reproduce themselves. They can produce copies, just like von Neumann imagined. And over 1 billion years, they can populate all the habitable planets in the Milky Way galaxy, including the solar system. Now, this is not a philosophical issue that we should debate about. The way to find out whether we live in such a reality is to look at the sky and search for equipment that was sent by other civilizations that predated us. That's all. And we should not repeat the mistake that philosophers made 4 centuries ago when they didn't want to look through Galileo's telescope and argue that they know that the sun moves around the earth. When you look at the sky, you see the sun moving. Therefore, it was very natural for them to believe that we are at the center of stage, so to speak. But they put Galileo in house arrest. Today, they would have canceled him on social media. But that didn't change the fact that the Earth moves around the sun, and we use that fact when we design space missions nowadays. So the fact that it was not popular back then didn't change anything. You know, humans can decide to be ignorant forever. We can decide not to look through our windows and argue that we have no neighbors, that we are the smartest, and ridicule on social media anyone that discusses this possibility. But that will not get rid of our neighbors. Next, please. So in July, I announced the Galileo project following a visit by several multi-billionaires to the porch of my home when they asked me questions about my book, and altogether provided me with about $2 million in research funds. And I decided to allocate them to this purpose of searching for objects near Earth that may be technological equipment from interstellar space. Because extraordinary conservatism leads to extraordinary ignorance. We should have learned that lesson because of the experience that Galileo had 4 centuries ago, but apparently we haven't. Just a few months ago, there was an article in Nature Astronomy magazine by a philosopher arguing that an unusual object that appeared near Earth, Oumuamua, that I'll describe in a few minutes, must have been natural based on philosophical reasoning. And I thought to myself, haven't we learned something? We need to dare to look through telescopes for the answers. And you can find more details about the Galileo project on the website provided in the middle of this slide. Next, please. So the Galileo project aims to study 2 types of objects. One is objects that arrive into the solar system from interstellar space, similar to Oumuamua that was discovered in 2017. And the other are objects that hover just above Earth in the Earth's atmosphere. Next. And the amazing thing is that, you know, an emitter-sized telescope that you can purchase on the web, you can add it to your bag for $500,000, turns out, that can obtain a megapixel image of a human-sized object at a distance of 1 mile. And that allows you to see the head of a pin on the surface of such an object. Again, it's not a philosophical discussion. It's a matter of getting a megapixel image. And then you can tell the difference between a label saying made by exoplanet X rather than made in China or made in Russia. It's simple. So one objective of the Galileo project is to obtain high-resolution images and monitor objects whose nature is not clear near Earth, in the Earth's atmosphere. These are called unidentified aerial phenomena, UAP. Next, please. And then the second component is to search for interstellar objects, objects that enter the solar system, arrive to the vicinity of Earth, and do not look like a comet or an asteroid. Next. And of course, for them as well, we would like to get a high-resolution image. Next. So you can, there is a website, a web link for anyone interested in supporting this project. And we have some significant level of donations from private citizens. And I got thousands of emails from interested people that wanted to contribute from their expertise to the project. By now, we have about 70 people involved in the project, and it's going extremely well. I must say, over a period of a couple of months, we are already selecting instruments and starting to test them. Next. And of course, this project was inaugurated about a month after the intelligence agencies delivered a report to Congress suggesting that there are aerial phenomena that are not identified, UAP. Next. And this is not a subject that the most conservative organization, the government, has to resolve. I mean, it's quite remarkable that the intelligence agencies admit that they are not doing their job. They cannot figure out the nature of objects hovering in the sky above the US. But at that point, it should not be the talking points of politicians or military personnel. It should go into the realm of mainstream science, where scientists should resolve the nature of these objects. And there were 143 of them reported. There must have been many more seen because of the stigma that there is on this subject. Next. And very reliable people, former CIA directors, Brennan and Woolsey, former President Obama, spoke about it as a serious matter. So the scientists should figure it out. Next. And that's what the Galileo project is all about. Next. Now, the big picture is that it's not clear whether we would survive for more than a few centuries. And of course, currently all our eggs are in one basket. But we should think about spreading them. And I call that Noah's spaceship, because you're all familiar with Noah's Ark, the biblical story where Noah tried to save animals from the great flood. There are many risks here on Earth, and we might want to save life forms that we care about from those. The only person whose remains left Earth is Clyde Tombaugh, whose ashes were put on the New Horizons mission. And actually, one of the members of the Galileo project was the principal investigator of New Horizons, Alan Stern. And I actually asked him, I said, it doesn't make much sense to put ashes of a person you want to celebrate on a spacecraft, because what are ashes? They are just burnt up DNA. It's as if you took the genetic information of a person and burned it up, so there is nothing left. It's no different than the ashes of a cigarette. But if NASA wanted to celebrate a person, they should have put the genetic code in electronic form so that someone finding that spacecraft will be able to reconstruct Clyde Tombaugh. Next. So we know that Earth is our home, but only for a short while. Next. Because of internal threats, there is a risk of climate change, wars, and other catastrophes that are self-inflicted. And there are also external threats. You know, we know that 66 million years ago, there was a giant rock the size of Manhattan Island that hit the ground and tarnished the ego trip of the dinosaurs back then. So there are all kinds of threats. Next. And we should go to space. And let me just say a few words about myself. I started actually on a farm in Israel 59 years ago. 1962 is the year I was born. You can see me at age 7 on the top left. I used to collect eggs every afternoon. I should say one thing led to another. And then in May 2015, Pete Warden and Yuri Milner, actually Pete is attending the conference, came to visit the Center for Astrophysics. And Yuri sat on the sofa in my office in front of me and asked me whether I'm willing to lead a project to visit the nearest star system, Alpha Centauri. And I immediately recognized it's 4 light years away, so it takes light 4 years to make the distance, and therefore you need a spacecraft moving. If we want to do it during our lifetime, it needs to move at around a fifth of the speed of light in order to get there in 20 years. And you know, that's 1,000 times faster than chemical rockets. And that's a huge leap. In April 2016, we announced the project in New York City in the company of Stephen Hawking and Freeman Dyson. Next. So this is an artist's illustration of the solar system, which goes halfway to the nearest star, which is Proxima Centauri in a 3-star system, the Alpha Centauri system. And the Oort cloud is just the building blocks left over from the construction project of the planets. These are icy rocks going halfway to the nearest star. So if any star has an Oort cloud, they are very densely packed throughout interstellar space. And it's easy for us to lose bricks from the Oort cloud. Next. Now, the nearest star, Proxima Centauri, has a planet. The star is only 12% of the mass of the sun, so it emits mostly infrared light. It's a dwarf star with half the surface temperature of the sun. This planet is 20 times closer to the star, but it happens to be in the habitable zone, roughly with a similar surface temperature as the Earth has on its day side. Turns out that it's tidally locked, so it shows the same face to the star, and there is a permanent day side and a permanent night side as it moves every 11 days around the star. And my daughters say that if we ever go there, they want to live on the strip that separates the day side from the night side. That's where you can sit on the porch and see the sunset forever. Next. And I asked students in my class at Harvard if they know of any animal that has infrared vision that they would enjoy the light coming from Proxima Centauri on the day side. And one of them found a shrimp that has eyes that look like ping pong balls connected with cords to the head of the shrimp. And she said, it looks like an alien to me. Next. So how do we get there? That's the Starshot Initiative. And the idea is to push a light sail with a very powerful laser beam and connect electronics to the light sail. Next. So this is a quick video that shows the concept. A lot of small, low power lasers combine their beams to make a very powerful 100 gigawatt laser beam. And if it shines on a sail that weighs a few grams, then within a few minutes, it can push it to a fifth of the speed of light. And the sail size is roughly the height of a person. That acceleration, this launch, goes for a few minutes across a distance that is 5 times the distance to the moon. And then after that, there is a journey of 20 years to Proxima Centauri. And of course, the hope is that we get there and the camera on board will take a photograph of this habitable planet and inform us whether it has life on it from a close-up passage. And it takes the photograph signal 4 years to reach us from that distance. So altogether 24 years, you need a lot of patience. You know, humans were not selected by Darwinian evolution to make interstellar travel. I think we should only think in the context of equipment. As far as what we send far out, And of course, other civilizations may have done the same. We shouldn't expect contact with living organisms. Next. And there is also a natural way for launching a sail close to the speed of light, and that's by parking it about 100 times the Earth-Sun separation from a massive star that is about to explode. And when a star goes supernova, there is a flash of light. And I calculated that it could carry a sail of the type used in Starshot near the speed of light. The situation is similar to those surfers on the beaches of Hawaii waiting for a giant wave to carry them, except here it's a flash of light doing it. And another metaphor is dandelion seeds that you can see on the right-hand side. Next. Now, we're probably not the sharpest cookies in the jar of the Milky Way galaxy. And by that, I mean, we're not the most intelligent civilization that ever existed. And the reason I say that is by looking at the news. I define an intelligent culture as a civilization that follows the guiding principles of science, which are cooperation and sharing of evidence-based knowledge. And you can easily tell by reading the news that we don't share much, we don't cooperate much. And moreover, a lot of what we do is not based on evidence. Next. So if I had to guess, I would say there was probably a smartest kid on our block. Next. But without prejudice, we should be open-minded and search. Next. And the best place to start the search is in our backyard. Next. Next. And the first object discovered from outside the solar system in our vicinity was found in October 2017 by the Pan-STAR survey on the summit of Haleakala Mountain in Maui, Hawaii. It was given the name Oumuamua, which means a scout in the Hawaiian language. You can see it circled in blue here on the background of stars that are moving relative to it. Next. And it started actually from a very special frame of reference, the so-called local standard of rest. That's the frame that you get to when you average over all the motions of all stars in the vicinity of the sun, sort of like the local galactic parking lot. And Oumuamua was at rest in that frame. Only 1 in 500 stars is so much at rest as Oumuamua was initially. Next. And of course, the sun gave it a kick gravitationally. Next. And as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that implied that it has a very extreme shape. Next. The best fit to the variation of reflected sunlight was that of a disk-like object, pancake-like. In these two plots, you can see a comparison between a disk shape and a cigar shape. And in both cases, the object had to be at least 10 times longer than it is wide because of the variations in the light curve. And a dark color implies a high probability. So on the left, you can see that for many different choices of the orientation, you get good agreement with the light curve, whereas for the cigar-shaped case on the right-hand side, only very fine-tuned set of parameters allow a cigar-shaped object to describe the data. So at the 90% confidence, it was most likely pancake-like. Next. And when the Spitzer Space Telescope looked at this object, it found nothing. You can see it on the top right image. There is no detection whatsoever of anything coming from the direction of Oumuamua. And that implied very tight limits on carbon-based molecules or dust around it. Not only we couldn't see a cometary tail, but also the amount of any evaporated carbon-based molecules was very tightly constrained, and it couldn't be a comet, definitely not a comet of the type that we have seen in the solar system, even though that was the favorite interpretation when Oumuamua was discovered. People said it's a comet because most of the objects in the Oort cloud would appear as comets. And that's the place where you expect rocks from other stars to come from. But it was definitely not a comet of the type that we see from the Oort cloud. Definitely not. And then it exhibited a non-gravitational acceleration, a push away from the sun. That was a Nature paper. And we actually analyzed the same data with my postdoc, and we confirmed their conclusions. It looked as if there is a force pushing this object that declined smoothly, inversely with distance squared. And no jitter, no cutoff at the ice sublimation distance, as you expect from the rocket effect, from evaporation. So it looked as if, to me, the only explanation that sounds plausible is that it's the reflection of sunlight that is pushing the object. And for that, the object had to be very thin. And nature doesn't make thin objects. So we wrote a paper where we suggested that maybe it's artificial in origin. Next. And that is really the fundamental question. Is Oumuamua natural or artificial? Next. And in September 2020, after I finished writing my book, the Pan-STARRS telescope discovered another object that exhibited an excess push away from the sun with no cometary tail. Next. And that was given the name, the astronomical name 2020 SO. No cometary tail implied that maybe it's an asteroid. That's what the astronomers thought initially. But then a few weeks later, next, they found that no, it's actually, if you track the orbit back in time, it came from Earth. Next. And moreover, it's actually a rocket booster that was launched in 1966 as part of the lunar lander mission then. And that's why it was pushed by reflecting sunlight, because it had very thin walls. It had a large area for its mass. Next. Next. And as a result, it behaved similarly to Oumuamua. So we know that this object is artificial in origin because we produced it. It was not produced to be a light sail. It just had thin walls. And I'm not saying that Oumuamua necessarily is a light sail. It may have been just thin for a different purpose. Next, 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 next. So what are the anomalies of Oumuamua? Next, next. First, it was not expected to be found. I wrote the first paper forecasting how many rocks we expect from other stars. In 2009, we wrote this paper with Amaya Morrow-Martin and Ed Turner, and we didn't expect Pan-STARRS to find any. And by not finding any, I mean by 2 to 8 orders of magnitude, too few for Pan-STARRS to find any. So there is a huge gap between what you expect based on what we know about the solar system and the discovery of Oumuamua. That was a surprise. That's why I was interested in it in 2017. It also originated from the local standard of rest. Only 1 in 500 stars originate from that system. Its brightness changed by a factor of 10 as it was spinning. It had a very extreme shape. Next. Most likely pancake-like. Next. And then the Spitzer Space Telescope didn't detect any infrared emission from it. Next. So it was small and relatively shiny, but most importantly, it deviated from a Keplerian orbit. Next. And to me, that implied that it's being pushed by sunlight, and therefore it's very thin. Next. Now, most people just said, most astronomers just said, oh, it's natural, business as usual. But some astronomers tried to explain, and I should remind everyone, these are observed facts through telescopes. There is no doubt that these facts were observed, so we need to explain them. You can't just ignore them and say business as usual. Next. So the people that attended to these facts found several explanations. For example, maybe it's a cloud of dust particles, 100 times less dense than air, very porous, so that it's just like a feather and it's being pushed by reflecting sunlight. The problem with that is such a cloud 100 times less dense than air will not maintain its integrity when it's heated by hundreds of degrees and gets close to the sun. Next. Then next, there was a suggestion, maybe it's an iceberg of molecular hydrogen, so that we can't see the evaporation because hydrogen is transparent. And the problem with that, well, first, we never saw a hydrogen iceberg. We don't know if it's made in molecular clouds. But moreover, such an object would evaporate very quickly within a few million years and won't survive the journey through interstellar space. Next. Then there was a suggestion, maybe it's a nitrogen iceberg chipped off a surface of a planet like Pluto around another star. The problem here is the mass budget. We showed in a paper that there is just not enough nitrogen in all the stars of the Milky Way galaxy. Next. So let me just illustrate with a few numbers. These are two papers that I co-authored with younger people. One showed that the hydrogen iceberg would get evaporated in a few million years. That's shown on the left, the evaporation timescale versus size. The other one showed that the nitrogen iceberg would get evaporated in less than 500 million years. That's the characteristic lifetime that was assigned to such an iceberg by the original authors of the paper. For that to be the case, so that it survives 500 million years, you need the initial size to be more than 10 kilometers. And it will end up in the size of 100 meters or so. So 99% of its size would get completely evaporated. Then you have a huge problem with the mass budget, huge problem. There is just not enough nitrogen. Next. And even if you didn't take this, even if you assume that the evaporation is not substantial, still you need more mass in exoplutos than you have in stars, basically, in order to make enough of those chips that would account for Oumuamua. And anyone interested in the details can look at the archive. Next. So my point is simple. If it's something we have never seen before, we might as well also consider the possibility that it's artificial in origin. Why ridicule that possibility? And this is a paper from the 25th of August, posted on the archive, co-authored by people that proposed the hydrogen iceberg model. And in the middle of the abstract, I highlighted in gray here, you can see the sentence saying that the hydrogen and nitrogen models have serious difficulties. That's not me, that's the people that proposed this model. Next. So as far as I'm concerned, when you walk on the beach, most of the time you see rocks that were naturally produced. These are the comets and asteroids that we have seen many times over and over again. Next. But every now and then, you see a plastic bottle. Next. And that could be Oumuamua. Next. Next. Now, if you imagine a caveman finding a cell phone, the caveman that is used to playing with rocks all of his life would argue, oh, the cell phone is just a rock of a type that I've never seen before. Just like saying, Oumuamua is a rock of a type that we have never seen before. A hydrogen iceberg, a nitrogen iceberg. We don't know if such rocks are common, if they could explain the first object we see, but it's something we've never seen before, and that's it. And of course, that's the beginning of a learning experience. Because if the caveman presses a button on this shiny rock, he would record his voice. And if he presses another button, he would record his image, at which point it will be clear that it's not a rock, it's something else. Next. Now, there was an interstellar object that looked like a comet. It was the second one discovered. Next. Called Borisov, because it was discovered by Gennady Borisov, an amateur Russian astronomer, and it looked just like a comet. And I was asked, what do you think about that? Here is a comet. Doesn't it argue that Oumuamua must be natural as well? And I said, well, when you go down the beach and you see a plastic bottle, and after that you see a rock, that doesn't make the plastic bottle a rock. So they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I wouldn't need to write the book if I had a picture like this one that was taken by OSIRIS-REx of the asteroid Bennu. And it actually took a sample from the asteroid that it will bring back to Earth in 2023. And so the idea of the Galileo project is to design a mission that would take a close-up photograph of another Oumuamua-like object that we discover on its approach to us. Next. And one thing to keep in mind always is that we are born to this world like actors put on a stage, and we tend to think that the play is about us. But it's not about us. The play has been going on for 13.8 billion years. We just came at the end. And the best way to find out what the play is about is to look for other actors. Maybe they had more time to figure it out. Next. And we can look in many different ways. Industrial pollution, city lights on the surface of, on the day side of, on the night side of Proxima B, beams of light that are used to propel light sails, or photovoltaic cells that have a special reflectance on the surface of planets. Next. And of course, there is this paradox posed by Enrico Fermi about 70 years ago. Where is everybody? Well, that to me sounds presumptuous, because it assumes that we are sufficiently interesting and special for them to come over and have a party in our backyard. And suppose, you know, they came 1 million years ago. We wouldn't know about it because our documented history is only 10,000 years old. Next. And most of them are potentially dead. Next. But instead of searching for radio signals, as we have been doing in SETI for 70 years, we should search for relics, for equipment. And it's sort of like archaeology, finding evidence for dead civilizations that predated us. Next. And my hope is that this will provide inspiration for the human species, because if you look at human history, the one repeating theme that you find is some humans, some people trying to feel superior relative to other people. And the best example is the Second World War, where the Nazi regime triggered the deaths of 75 million people. That was 3% of the world population in 1940. It's 20 times more than the number of deaths caused by the COVID-19 virus. And we keep talking about COVID-19 all the time. That's 20 times more just by a group of people trying to feel superior relative to other people. And my point is, if we find a smarter kid on the block, a civilization that is far more advanced than we are, just imagine the Perseverance rover, instead of finding evidence for some early life on Mars, instead of finding evidence for microbes, it bumps into the wreckage of a spaceship that represents a technology far more advanced than we ever used. Perhaps that would inspire us to ignore our small genetic differences and cooperate as equal members of the human species. Thank you. I'll be glad to answer any questions.
Avi, I hope you can hear the applause in the room here. We're going to limit ourselves just to one question. Dennis?
Great. Our question is, why is Oumuamua always depicted as an elongated rod-like object, while the probability is 90% to be a flat disk?
That's because this depiction was made by an artist. And so what we knew from the light curve is that the variations are by a factor of 10. And it means that the surface area of the object projected on the sky changed by a factor of 10, because if the albedo remains constant. And think about a piece of paper tumbling in the wind. When you look at it sideways, it looks like a cigar, but intrinsically it's flat. So if you analyze the reflection of light from the object, at the 90% confidence, you infer that it's flat, but projected on the sky, it sort of looks like a cigar. And I think the artist was just wrong in plotting it as a cigar. Yes.
Thank you.